We might not notice, but tremendous technology and mind-boggling science constantly surround us in the products we use every day. Behind their practical use lurk hidden histories, dramatic discoveries, and awesome experiments. They are Wicked Inventions. Coming up, kayaks. We discover how to cook a kayak. Aerosol sprays. What is the connection between soda and our indispensable dispenser? Carpet. Chemical twisting, natural wool, and yarns galore. We reveal the fascinating production of this fantastic floor covering. We reveal the surprising science and amazing manufacture behind these wicked inventions. Kayaks have been made in all different shapes and sizes for years, for enjoyment and travel on water. But just how were they introduced?
Kayaks really emerged thousands of years ago, especially in the northern hemisphere with some of the indigenous people. Now, originally they would have been very simple timber frames with seal skins or any kind of skin they'd have to hand wrapped around them. The base of these kayaks would have bladders inflated in them, so they were pretty much virtually unsinkable.
Despite the early history and development of kayaks being shrouded in mystery, it is clear that over time, the idea of a smaller and shorter method of transportation on water has always been the priority. However, these tiny watercrafts have been heavily adapted to what we know as kayaks today.
Kayak itself means hunter's boat. The river gives them their life, their economy, everything. Hunters are going out there, then you've got people who are trading, so they need these wider platforms, and a kayak was always a very stable structure for this. Well, they can move very easily, so actually navigating around small river network systems, if you're using it as a hunting platform, the ability to kind of move and change as your prey is moving and changing makes this the kind of ideal boat. It wasn't until about 1905 when a German called Klepper was kind of travelling in this area and saw indigenous people using kayaks that he came back to Germany and created what he called the fold boat. So this was like a folding frame with canvases around it.
The creation was made for a student of Klepper's, but the design caught on and began to be made in mass, sparking an increase in the kayak's popularity.
You also then see the kind of the evolution of the very long, narrow boats. Especially you see them in the South Seas. These are designed for speed, they're very closely linked to the surfboard.
These adaptations led to the slow introduction of kayaking as a sport. Kayak races were introduced in the Berlin Olympic Games in 1936. Now kayaking is still an Olympic sport, and those of all ages now paddle on waters around the world. But just how are they made? Jackson kayaks are designed with the assistance of kayak world champions from different categories. This has led to them creating some of the best boats in the business.
Jackson Kayak was founded in 2004 by Eric Jackson and Tony Lunt. We started with whitewater boats and expanded into fishing and other flatwater markets.
The process starts with large cast aluminium molds, which are built according to a computer-aided design or CAD model. The molds have a steel frame built around them so that the different machines used in the forging process can easily support and move the mold. Before the first step of the kayak building process begins, the mold must be prepared. A release agent is sprayed onto the inner surface, which prevents any of the kayak's materials from sticking. Mold-in graphics are then added to the mold. These are the images, text and logos that will be positioned around the finished kayak. The mold-in technique is used because these kayaks need to be used for a very long time without deteriorating, and stickers would degrade and peel away. Next, the powdered plastic materials are placed into the bottom half of the kayak's mold. When the mold is placed into the oven, these powders will melt into a liquid plastic that can run into every detail, shape and recess of the mold. Each type of boat has a specific way the powders must be distributed to ensure the liquid plastic can reach all areas of the mold and form a complete boat hull. The top half of the mold is then joined up with the bottom, which forms a sealed unit. Large overhead cranes connect to the metalwork around the mold and lift both sections into the open oven. Once the mold is inside the oven, rotational axles support and secure it in place so the crane can be moved and the clamshell door can be closed. Each type of kayak has a specific recipe which must be used in order to cook each boat properly. The operator inputs this into the computer and the cooking cycle begins. Now the oven can be left for around 30 minutes.
So the entire oven is going to be moving, rocking and rolling at the same time, moving that powder everywhere we need it to get to. We have 59 different molds we're running, so it's a lot of small parts to keep up with and make sure we have the right parts for the right boats for the right ship dates.
Once the cooking sequence is finished, the oven returns to a level position and the operator opens the clamshell door. The same crane from earlier is used to lift the mold out of the oven and over to a cooling station. Here the molds rotate around a wheel, which cools the plastics inside at the same rate. Once their temperature decreases to around 250 degrees Fahrenheit, the molds are removed from the cooling wheel and placed on the ground. The moulding crew now opens the many clamps which hold the mould shut and attempt to open it. The crane is used to lift the top of the mould away whilst the crew prizes the kayak out. This can be quite tricky due to the rim of the cockpit getting stuck, so gloves and plenty of force are needed. The new kayak hull is moved to a separate cooling fixture which maintains the kayak shape as the plastic cools, since the materials are still very hot and therefore very flimsy. Whilst the boat is held in the cooling fixture, a series of quality checks are carried out. Visual checks are completed to make sure there are no strange defects to the surface of the boat, and ultrasound checks are performed in over 30 places. Ultrasound is capable of checking the internal structure of the plastic hull, making sure it is thick enough to cope with the rough life the boat will endure. Next, the cockpit must be trimmed out. Since the mould formed a complete seal around the plastic, the boat inside is also completely sealed. This means there is not yet a hole to sit a kayaker inside. A craftsman uses sharp tools to cut, trim and sand the cockpit area, leaving a smooth entry point for the owner. On the other side of the factory, the components that fit inside the kayak are being formed. A vacuum forming oven is used to heat up a large sheet of high-density polyethylene plastic, which makes it soft and malleable. Once the sheet has baked for long enough, the plastic is positioned over a mould. A strong vacuum pump is then attached, which pulls the material tightly against the mould, forcing the sheet to take its exact shape. The new kayak parts are left to cool and harden before they are cut out and prepared. It is now the job of the master boat builders to assemble the remaining components into the kayak. Foam sections are fixed into locations around the kayak so that should it fill with water, the boat cannot sink. For added comfort, a cushioned seat and knee pads are added too. Finally, a skeg is attached to the underside of the kayak. This is a deployable fin which helps the kayaker paddle in a straight line. The skeg has a cable attached to it, which is fed through the boat and up to a clam cleat. This part can hold and lock the cable at any length, giving the user full control over how they want the skeg to be deployed. 45 minutes after the master boat builders began, the kayak is shipshape and water-worthy. But before the boat can be sold, every kayak must go through one more line of quality control. If the kayak passes, it is cleaned and packaged in layers of plastic. This protects the boat whilst it is in storage, waiting to be shipped to dealers.
We're really proud that most of our parts we actually source as locally as possible. There's a few parts out there that we can't get local. One part that we're okay with is our clam cleat. It actually comes from England. It's one of the about 4 or 5 parts in our building that aren't made here.
Soon these kayaks will be zipping along the water on lakes, rivers and seas around the world. The kayak, a wet and wicked invention. From keeping your hair in place to pesky insect protection, the invention of the aerosol can has transformed our ability to dispense a wide range of products, from paints to lubricants. But what is an actual aerosol?
An aerosol is a particle in the air, quite simply. So smoke from a fire is producing aerosols. Soot, dust, they're all aerosols because they're suspended in the air. When we come to talk about aerosol sprays, it's about how do we put particles into the air in a controlled manner.
The secrets to controlling aerosols was pressure and the ability to release it in bursts. We may consider the aerosol spray can as a thoroughly modern 20th century invention, but engineers and manufacturers had been trying to design systems that could dispense pressurized drinks as early as the late 1700s, with the valve for the pressurized soda fountain being developed in the 1830s. The two breakthroughs in the production of the aerosol can was the ingenious valve invented by Norwegian engineer Erik Rothheim in 1927 and the industrial production of aluminium.
The Washington Monument has a cap on top of it made of the most expensive material at the time, which was a 9-inch pyramid of aluminium. A few years later, after the Washington Monument was built, electrolysis was discovered. Aluminium was then being able to be made in vast quantities and very, very cheaply. That invention essentially allowed modern-day pressurized canisters and aerosol sprays to be made.
The development of the aerosol grew in leaps and bounds during World War II, as the US government granted funding for the development of a portable means for servicemen to spray insecticide in order to kill malaria-carrying bugs. The solution, which came in the form of a small aerosol can, which was pressurized by a liquid gas, was widely used in the Pacific Theatre, and further development resulted in cheap and lightweight aluminium cans, which could practically disperse liquid foams, powders and creams. So, how does an aerosol can actually work?
An aerosol can is essentially a pressurized canister of any kind. It doesn't have to be the small shapes that we're used to. It has a valve on the other end of it that you can open and release the pressure. When you release the pressure, the gas inside, which is the propellant typically, is mixed with some other material, and that sprays out. And because it becomes very finely divided as it comes out, it lands on whatever surface in a nice, even application.
Today, aerosols are extremely versatile, dispensing sprays, foams, gels and powders. Aerosols also have a long shelf life because they are airtight, clean and hygienic, so the product inside does not deteriorate. The secret ingredient to the spray can's success is the propellant. The propellant is the material that actually forces the substance to be used out of the canister. The propellant is usually inert, which means chemically it does not react with the product being sprayed. In the past, CFCs or chlorofluorocarbons were commonly used as propellants, but their use and the dangerous link to the depletion of the Earth's ozone layer has resulted in other materials now being used.
A lot of the propellants in pressurized canisters for aerosols tend to be hydrocarbons. So your butanes, your propanes, your isobutenes, they're all very light liquids molecularly, and what it means is that under pressure they're a liquid, but as soon as you release that pressure by opening the valve or pushing the button as you would on the deodorant, that means they suddenly start to turn into a gas. And that pushes all of the material that you want that's dissolved in them up and out of the aerosol spray, and you can direct it wherever you want. You have now an atomized, not quite literally, but small particles in the air that spray and land on whatever surface you direct them.
With around 12 billion aerosols used annually worldwide, the spray can has become an everyday essential. We might recognise its features, but do we know why they look the way they do? For instance, the curvature on the bottom of the aerosol can not only provides greater structural integrity, but also makes it more efficient in terms of being able to use nearly all the product in the can, with the end of the straw sitting in the corner of the canister. And what about the rattle sound we hear when using spray paint? Developed in 1949, with aluminium being the first available colour, the spray paint can has a metal ball bearing lurking inside to help mix the paint.
The paint mixture itself isn't very easy to mix with the propellant, so when you have a paint canister for spray paint, you have to shake it quite a lot to help mix it. The ball bearing goes back and forth. That ball bearing going back and forth moves through the fluid in the can, and that movement through pushes the liquid inside against the edges and forces it to mix very quickly. It also mixes with the propellant. When that happens, obviously, you can then spray it efficiently, effectively, and nice and evenly over the surface that you need to spray paint. And it also means that the paint itself, which is often a mixture of oil and other materials that don't always mix so well, can be nice and easily applied. But it's also why spray paints tend to smell quite a bit, because they need something to evaporate very quickly on contact. Otherwise, they will drip.
From hairspray to paint, the aerosol can is truly a wicked invention. Can we create a pressurized water rocket from plastic bottles? We're going to need 2 2-litre plastic bottles, duct tape, pieces of card, a cork, scissors, craft knife, a nail and a stone or small weight. To begin, we create the nose cone of our rocket from one of the bottles and place a stone under the cap that will make the rocket stable in flight. Next, we fix the cone to the other bottle with tape, adding further tape to reinforce its walls. We then create the fins of the rocket from the card and fix them to the plastic bottles. We take the cork, halve it, and very carefully push the nail through its middle to create a small hole that will snugly fit a foot pump needle. Moving outside, we fill the rocket a third of the way with water and tightly fit the cork. We insert the foot pump and we are ready for takeoff. We pump the bottle with air and eventually it will take off with a dramatic whoosh of air and water. Like an aerosol can, air is added to the rocket, which creates a continuous buildup of pressure, and this eventually leads to the cork being forced out of the bottom, and the force of the air and water exiting the bottle pushes the rocket into the sky. Can we create a pressurized water rocket from plastic bottles? Yes, we can. Wicked challenge smashed. Over time, carpets have provided great insulation and fantastic decoration, but just how were they introduced?
Well, the origins of carpets are shrouded in mystery. Obviously, they go back centuries. It's believed that they would have first been a form of knotted carpet in around 7000 BC, but this is across different nationalities, different nations of the world, and so it's very difficult to pinpoint the exact origin of carpets.
These first type of carpets had the primary use of insulation and protection. They were also not tailor-made, meaning they wouldn't always fill a room.
It did become a status symbol, so how you decorated, how intricate and decorative were carpets, it mattered a lot to the different nationalities, different cultures.
Like most Wicked Inventions, carpets were seen as a status symbol because of their expensive price, which is due to their rarity.
And then this evolved over time, developments in how materials were made, and actually the skills as well. So people would develop skills and become better at hand weaving carpets. Then into the Industrial Revolution, obviously this changed everything. Mechanization, processes, different materials, improvements in making carpets. It changed everything and it became more accessible.
We then saw carpets become a household commodity, losing its status symbol. The carpets woven from the years following the Industrial Revolution are known as modern carpets today. The only difference has been the size and the amount of decoration.
It went from rugs that you would have strategically placed around your home to this wall-to-wall carpets. Developments in different types of glues, different synthetic materials evolved over into the 20th century.
A fine example of such decoration is the red carpet. These long and narrow carpets are used to signify the route taken by those of importance before and after ceremonial and formal occasions, such as weddings or film premieres. We now see carpets in the rooms of most households, but just how are they made? Wool is all around us, and it has hundreds of uses. Brintons have been using it to make carpets and rugs since 1783.
So Brinton's, as a family-owned company, was established over 230 years ago in the world of textiles, manufacturers of carpets, so they've been around for quite a long time. In Worcestershire, servicing all corners of the globe in the art of floor coverings.
When the bales of compressed wool arrive at the factory, they are unwrapped and placed onto a conveyor belt. This belt takes each bale into a blending machine, where spiked rollers pull apart the woolen fibres. Nylon fibres are also added here, and the spiked rollers blend these in. The resulting material has a mix of 20% nylon and 80% wool, which means the products made from this will feel soft while still being strong.
Blending is literally, as the word kind of describes, it is mixing and creating a healthy distribution of the wool.
Brinton's makes a lot of different rugs and carpets, which requires a lot of different colours of wool. To make this possible, they have developed the most extensive dyeing facility in the world, with thousands of colours available, which are all measured digitally. To colour the wool, it is compacted back into a bale and placed into a vessel. The vessel is then lowered into a pressurization tank, where the dye is injected. After the colour has taken, the wool is spun once more to remove any excess dye.
Stock dyes are very, very useful processes when you're doing large expansion of areas in the commercial world, like airports and ships, where there's a plain ground colour and you need consistency and levelness.
The next step is carding. Here the material is fed through more rollers that rotate at different speeds. This pulls the fibres apart from each other, straightening them out and aligning them at the same time. A lighter, straighter material is the result, which is very delicate, so it is moved to the next machine using a slack wooden conveyor. Next, the wool is spooled into a strong yarn that is suitable for some carpets.
It produces what we call a strand or a slubbing at the end of the card, which is the start and the creation of a thread of yarn.
Step 3 is where the yarn enters the spinner, which twists and tightens the thread in 2 stages. The first is winding. Here an individual end is twisted around itself and it is elongated slightly. The second stage is twisting.
So twisting is taking the parallel strands of yarn that we just discovered in winding and twisting them about each other, so that this then creates a 2-ply yarn. You can do it with 3 threads as well, but the idea of creating a 2-ply, which is the most common yarn that we use here at Brinton's, is to create this strength of what then ends up to be a strand of yarn.
Next, the yarn undergoes a process called chemset, which is where a chemical is added to keep the twist in shape. A chemical is added to the fibres, which leaves them swollen and malleable. Then the threads are pulled into a set shape. As the chemical dries, the fibres reduce in size and the twist is set. The wool is now ready to be woven, so it is transferred to the loom and prepared. The Axminster loom creates the weave found in Axminster carpets. These are some of the most durable carpets around, well known for retaining their appearance over a long time. The cut tufts of yarn are inserted into a backing material and binded closely to create the carpet, with around 10,000 square metres of carpet being made every week.
These machines these days can sort of handle 32 colours of individual threads and create designs that are more like floor art, if I'm honest. They're fantastic, and that's Axminster weaving for Brinton's. It's high definition.
The carpet or rug then undergoes inspections in order to check if there are any imperfections or tufts of wool in the weave. The tufts can be pulled out by a skillful hand, whereas imperfections require a little more work. If the quality is sufficient, the wool moves on to latexing. Here a firm latex backing is applied to secure the yarn fibres to make sure they don't move. This is also the stage that any bug protection is added to ensure moths and other insects stay away from the carpet. The carpet is inspected once more to guarantee customer satisfaction before it is placed onto large reels and packaged. The reel is then loaded onto lorries and dispatched, ready to become comfortable flooring in homes around the world. The woolen carpet, truly a wicked invention. So, there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day but have never realised their amazing backgrounds. Kayaks, aerosols and carpets, all wicked inventions.